Hello everyone, welcome to my YouTube channel Self Study. Today we will continue the third part of this chapter number 6, heat transfer. So continue the chapter. Superficial expansions of solid. When a metal plate is heated, its length, breadth and both increases. This increase of the area of the plate. Experimentally, it is observed that the increase in area of a metal plate depends on first, the initial area of the plate. Larger the initial area of plate, more is the increase in its area on heating. The increase in temperature. More is the rise in temperature, more will be the increase in area of plate. Third, material of the plate. A brass plate expands more than iron plate of same dimensions for the same rise in temperature. If A naught is the area of plate at 0 degree Celsius and AT the area of plate at T degree Celsius, then increase in area is given as AT temperature minus A0 is equal to A0 beta T, where beta is the coefficient of superficial expansions which is different for different solid or material. Cubical expansions of solid. When a solid is heated, it expands in all directions. Example, its length, breadth and thickness increase. Thus, the volume of solid to increase. Experimentally, it is observed that the increase in volume of a solid depends on the initial volume of solid. More in the initial volume of solid, more is the increase in its volume. Second, the rise in temperature. More is the rise in temperature, more is the increase in its volume. Third, the material of a solid. The brass ball increases in volume more than an iron ball of same radius of the same rise in temperature. If V0 is the volume of solid at 0 degree Celsius and Vt the volume at T degree Celsius, the increase in volumes is given as Vt minus V0 is equal to V0 gamma T, where gamma is called the coefficient of cubical expansions of a solid. It is different for different material. Relationship between alpha, beta and gamma. The three coefficients alpha, beta and gamma are related as beta is equal to 2a and gamma is equal to 3a, or alpha, beta, gamma is equal to 1 ratio is to 2 ratio into 3. It means 1 ratio into 2 ratio 3. Some applications of thermal expansions of solid in daily life. Number 1, constructions of a bridge. In the constructions of bridge, steel girders are used. One end A of the girders is fixed in concrete, but the other end B is not fixed into concrete. It is supported on roller as shown in figure 6.7. One end is fixed, another is rolled, so that if there is any rise in temperature during summer, girder may expand so that it may expand without affecting the pillar and bridge. Number 2, railway track. The rails of a railway track are made up of steel. While lying the railway track on wooden or concrete plank, a small gap is left between the successive length of a rail. As shown in figure 6.8, a small gap is there. The reason is that in summer, due to considerable rise in atmospheric temperature, each rail tends to increase in its length, so a gap is left between the two rails. Otherwise, the rail will bend sidewise. Riveting. For joining two steel plates, they are placed one above the other, and holes are drilled through them. The rivets, small steel rods, are heated red hot and then they are inserted in hole of the plate. On heating, the rivets become soft so that ends are easily hammered as head. Now the rivets are allowed to cool. On cooling, they contract, but they cannot regain their original size as they have been harmed, so they bring the plate closer and firmly grip them together, making the joint waterproof. Such rivet is used in joining steel girders, boilers, plate, etc. Electric cable and telephone wire. The electric cable in a overhead power transmission line and the telephone wire between two poles may break in winter due to constructions and may sag in summer due to expansions. Therefore, while putting up the wires between two poles, care is taken that in summer they are kept slightly loose so that they may not break in winter due to constructions, and while lying them in winter they are kept tight so that they may not sag too much in summer due to expansions. If you see, the electric wire are kept loose in winter, they are kept tight, while in winter they are kept tight. In summer means they are loose, and in winter they are tight. Fitting the steel rim on a horse cart wheel. The wooden wheel of a horse cart is fitted with a steel rim to make it strong and smooth. To ensure a tight fit of a steel rim over the wooden wheel, the rim is made slightly smaller in diameter than the wooden wheel. Then to fit the rim in the first heated uniformly along its circumference, steel diameter becomes slightly more than that of the wooden wheel. The rim is then slipped over the wooden wheel before allowing to cool. On cooling, the rim contract and make the tight fit over the wooden wheel, as there is a steel rims in a wooden wheel. Glassware used in kitchens. The glassware used in kitchens are slightly made up of Pyrex glass. The reason is that the Pyrex glass has a very low coefficient of cubical expansion, so the glasswares on being heated do not expand much and therefore they do not crack. Pendulum of a clock is made up of inware. Inware is alloy of iron and nickel, and it has a negligible small coefficient of linear expansion. The pendulums of inware make the clock neither to lose time in summer due to expansions nor to gain time in summer because of contractions. Loosening a glass stopper or a metal screw cap. A glass stopper on a bottle is loosened by warming the neck of a bottle. The reason is that on warming the neck of a bottle, the neck expands and the glass stopper it gets space to loosen. If there is a metal screw cap on the neck of a glass bottle, the screw cap is heated. On heating, the screw cap expands and it gets loosened. Cracking of thick glass tumbler. When a hot liquid is poured into a thick glass tumbler, it cracks. The reason is that glass is poor conductor of heat. When hot liquid is poured into a tumbler, the inner surface of tumbler becomes hot while its outer surface remains at a room temperature. Therefore, the inner surface of tumbler expands while its outer surface does not expand. These unequal expansions crack the tumbler. Thermal expansions in liquid. Like solid, liquid as also usually expand on heating. Liquid expand much more than solid when heated. Liquid do not have a definite shape, but they have a definite volume. Therefore, the liquid have only cubical expansions. Exceptions. Water contract on heating it from 0 degrees Celsius to 4 degrees Celsius, and then beyond 4 degrees Celsius on further heating it expands. This is called anomalous behavior of waters. What is anomalous behavior waters? Means beyond 4 degrees Celsius on further heating it expand, means water start expanding. The cubical expansions of liquid on being heated can be demonstrated by the following simple experiment. Experiment number 1. Take an empty bottle with a tight fitted cork having a hole drill in its middle, a drink straw, 2 bricks, a wire gauge and a burner. 2. Fill the bottle completely with water and add few drop of ink in it to make it colored for easy contrast. Fix the cork in the mouth of a bottle and pass the drinking straw through the cork. Put some malted wax around the hole so as to avoid the leakage of water. Pour some more water into the drinking straw so that water level in the straw can be seen, making the water level in the straw as figure 6.12. Thermal expansions of liquid. Place The bottle on a wire gauge kept over the two bricks as shown in figure 6.12b. Heat the bottle using the burner. Means the experiment of water, thermal expansions of liquid, how it expand on heating. Number 6. Look at the level of water in a straw. You will notice that as the water is heated more and more, the level of water in the drinking straw rise. This shows that water expand on heating. Explanation of thermal expansions of liquid by molecular motions. In a liquid, the molecules are free to move anywhere within the liquid. When a liquid is heated, the average kinetic energy of its molecules increases. As a result, the molecules begin to move more vigorously, thereby increase the intermolecular separation. Thus, the liquid expand on heating. Factor affecting the cubical expansions of a liquid. The cubical expansions of a liquid depend on the following three factors. Original volume of the liquid. Larger the volume of liquid take, more is the increase in its volume on heating. Rise in temperature. Greater the rise in temperature of a liquid, more is the increase in its volume. Third, nature of liquid. Equal volume of different liquid when heated to the same temperature undergo different increase in their volume. If V0 is the volume of liquid at 0 degrees Celsius and Vt the volume of liquid at 0 T degrees Celsius, the increase in volume of liquid is given as Vt minus V0 is equal to V0 gamma T, where gamma is the coefficient of cubical expansions of liquid. Different liquid have different cubical expansions. Experimentally, it is observed that equal volume of different liquid when heated to same temperatures expand by different amount. This can be easily demonstrated by the following activity. Activity number 4. I will discuss it later. Now table given below, given the coefficient of cubical expansions of some common liquid. Number 1, mercury 1.8 cubical expansions, water 3.7, paraffin oil 9.0, turpentine 10.5, alcohol 11.0, benzene 11.8. Now applications of thermal expansions of liquid in daily life. Thermal expansions of liquid is used in the working of mercury thermometer. We have read that a mercury thermometer consists of a capillary tube with one end closed and a cylindrical bulb at the other end. The bulb is filled with mercury. Mercury is a shiny liquid, so its level can be seen easily in the capillary tube. When the tube of a thermometer is kept in contact with a hot body, mercury expands. The level of mercury rises in a capillary tube. The tube is graduated to read the temperature. For each degree rise in temperature, mercury expands by the same volume, so the calibrations of thermometer become easier. Thermal expansions in gas. Gas also expand when they are heated. Gases expand much more than liquid and solid. Like liquid, gas do not have a definite shape, so they also have only the cubical expansion. Therefore, thermal expansions of gases can be demonstrated by the following simple activities. Activity number 5, I will discuss it later. Now, explanations of thermal expansions in gas by the molecular motion. In a gas, molecules have more intermolecular spacing amongst them. On heating, the average kinetic energy of molecules of gas increase and they begin to move violently in all space available to them for motions. As a result, the intermolecular separations further increase, so they expand. Variations of density with temperature. When a substance is heated, its volume increases while its masses remain same. Therefore, the density of substance decreases with the increase in temperature. In case of solid, when temperature increase in volumes is very small, and therefore decrease in density is not applicable. But in case of liquid and gas, as temperature increase, volume increase by an applicable amount of therefore decrease in their density is quite considerable. Exception: water contract on heating from 0 degrees Celsius to 4 degrees Celsius. So the density of water increase on heating it from 0 degrees Celsius to 4 degrees Celsius. On further heating above 4 degrees Celsius, the density of water decreases. Thus, water has maximum density at 4 degrees Celsius. So thank you for today. Please subscribe to my channel for the next chapter. Thank you.